My name is Richard Atwood, and I'm a software engineer at Intel. Specifically, I work on the technical consulting team, and what that does is we work like this and directly with customers to help understand the needs of the community, to see what kind of issues people are experiencing, and to help educate those customers on what tools are available from Intel to best and help them solve their problems. Specifically, what we're talking about today is Intel System Studio for IoT developers. And what I'll do is I'll go through an overview of the different features and components of those tools. A little bit, I guess, about me as my introduction is I am here in Oregon, so it's bright and early. Hopefully it's a good time for all of you. So with that, I'll just jump right into the presentation. Okay, so Intel System Studio, I mentioned that in my introduction. What that is, we have taken a number of the different tools and components that we thought that IoT and embedded developers might be interested in and embedded them into one combined tool suite to enable people to have a unified workflow where they can use one package to accomplish all their different tasks. One nice way to look at Intel System Studio and what it does is when you're building a product, there's many steps or stages or phases that your product might go through, different parts you might use between initially conceiving the idea to having a final product. And as I mentioned, that unified workflow is something that we're striving for with this combined tool suite to help enable you with that journey. So to start off, the initial step is choosing your hardware, choosing which products you want to develop with. And so we have a number of tools focused around each of the different kinds of hardware that Intel currently offers. And as you're designing a board or a system around that hardware, then we have tools to help you bring it up and get started. And that kind of steps us up to the next step, that in that same unified flow, when you're writing your firmware for those devices, where you run a BIOS or any low-level drivers or firmware, then we have tracing and debug tools to help you identify issues and performance areas in that firmware development. And then once your system's ready for an operating system and you're bringing that in, then we have two tools again for performing analysis, debug on operating systems and at that level. And then once that is complete, taking the next step higher for those application developments. And I think this is probably an area that is particularly of interest to many of the IoT developers. We provide compilers and optimized libraries and again, profiling tools to help you make sure that your applications are efficient and optimized for the different workloads that you might have in this IoT space. And then that everyone's favorite buzzword, the cloud, is once you have those applications optimized, you're probably going to want to be sending some data through the internet. And so we've added in the latest version of the tools, interfaces for cloud connecting to the cloud straight through that continuous workflow that I just described with the different features of the tools. How we kind of think of this functionality is there's kind of three main points that we really like to focus on. So one is that end-to-end solution, that idea that if you need to do something to build your system, to improve your system, to program, debug, those things, we want to make that experience as seamless as possible with this suite of tools. And then while doing that, we want to help accelerate your time to market. And simply what that means is we want to help developers to be able to get their product stable, efficient, and ready to market faster than you would be able to do otherwise. And then also, since our tools are custom for Intel hardware, the goal there is to bring out the unique features and functionalities that Intel hardware provides and to allow you to optimize for those specific things. So going to the next slide here, what we have here is kind of it's a lot going on this slide, but what I really want you to think about here is these are the different features and functions of the tool. But the key point, I think, that I want you to take away here is that the Intel System Studio product suite is available for all the different hardware platforms that Intel supports. So if you're doing something on the IoT or on the edge, then we support those Atom and low-level gateway processors. And then in the mid-range, if you're doing something on a desktop or tablet, then we support all the core processors. And then if you're working on embedded servers, for example, then we also support the Xeon product line. So what tools and what functions would be most interesting to you is dependent on what your workload is, but there should be components in there for your embedded development for each of the different hardware platforms. And here on the next slide, again, I know it's a lot of information. I believe you're going to have these slides, so don't worry about memorizing everything I'm showing here. But what this is to kind of give you an overview of is I want to give you a snapshot of the kind of different workflows that we envision for developers as you're using our tools. And of course, tailor them to your needs, but this is how we sort of structure it. So the first workflow is debug and trace. As I talked about in the previous slide, the goal there is to provide you the different system level different system level debug and bring up tools you might need. And so we have a couple of different tools, which I'll go to in detail later in the slides, specifically around designing a new board, designing a new IoT device, and bringing it up for the first time, making sure that it boots properly, which can be very difficult to debug, and making sure that you're able to understand how the product is functioning. And then once you're able to boot and bring it up, the natural next step in there is to analyze the code that you've written, analyze the performance of your device, analyze the power consumption. And so we provide a number of different analyzers and performance tools to help you see exactly where you can improve and where you can customize the performance of your application to make sure that it's as efficient as possible. And again, I'll go through the details of those in the slides. Then the next category, also very important, is once you're ready to write your applications or to develop the code on this platform that you want to work with, we provide an integrated IDE to bring this all together. And inside of that, depending which host, you'll get a different IDE. And inside of all of that, we've put in Intel's highly optimized C, C++ compiler, and a number of optimized performance libraries to help you get the most impact out of your code with the minimal amount of effort. And again, new in the 2018 version, we've also added, as I mentioned before, cloud connectors and then a collection of IoT sensor libraries to enable the low-level development of different IoT sensors in a more efficient way. So that's the high-level overview. And remember, if you have any questions, make sure just write them in the chat or something. I can't see them right now, but I will see them at the end. So put them in there, and I'll try and get to them all when we're done with the presentation. So going in, let's first talk about the bring up tools and what features we offer there to enable developers. So this is a smaller version of that previous slide, and we've got a little box drawn here on the right side, if you can see that. So that is the debug portion of our tools. And we have a number of different tools inside there, depending on what kind of workload or what kind of task you want to accomplish. And the three main tools that are available in this thing is first the Intel System Debugger, which, as you might be able to guess, is for doing system debug. So that is when you are building your system and you're bringing it up and you're running along as any debugger does. You set some breakpoint and you stop and you see, well, what's going on at this exact moment? And you can identify then what issues might be occurring as you're stepping through your code. Some people do all their debugging through simple things like printfs, and statements like that. And while that can work, it can be also very difficult. So having an IDE-based advanced debugger that allows you to dive deep into specific issues definitely increases your ability to analyze problems and increase your efficiency to be able to debug them and resolve what's going on. The next main tool that I want to talk about, also part of the System Debugger suite, is called System Trace. So we just talked about System Debugger. So what that does is it looks at your system performance in a moment in time. Well, System Trace, on the other hand, allows you to record the process of your boot process or the cycle that you're running for a certain period of time and see all the different steps that happen along that way. And while Debugger is very useful for defining issues in a moment, System Trace is very useful for defining a flow problem or a problem with the logic of the system where maybe your code, and I'm sure for all the developers out there, this has probably happened to you before. I know it's happened to me. When you run your code and it doesn't go where you wanted it to go. It doesn't go where it seems like it should go. So System Trace will allow you to see, well, where did it go? And why isn't it going where I expected? Why isn't it hitting that breakpoint? and we have a number of complex rules to support that. The next one is debug extensions for WinDBG. So that is if you are developing on Windows and you want to do customized things such as Windows driver development, then we have extensions specifically for Intel to improve your performance using that tool. And I mentioned the 3 probes here, but what I want to do actually is I'll just go to this next slide here, and I'll give you a nice picture. Visuals are always better, right? Of some of the different debug probes that we offer. This is a common problem, especially in IoT, is knowing how to connect to your target properly to do your debug and analysis. And Intel is working to sort of reduce the complexity in that and to create a more unified experience and approach into the debugging world. And as JTAG is the standard for most of the system program debugging tasks, we've created 2 more universal approaches to being able to enable your debug with JTAG. So the first one you see here on the left side is a very simple implementation where you just need a debug USB cable, and that's all it is. And so your target system would simply need a USB port of some sort, and then your host system running Intel System Studio could then run the debugger over that USB cable. And that is generally the preferred option for workloads that do not have to maintain through a power cycle. The idea being that it's pretty universal. USB ports are on most devices these days, or if you're designing a device, you could put one on there, and that removes the requirement to have a JTAG header later in your development cycle. If you do need to be able to debug through boot, then we have the one on the right here, which is a similar interface, also connectable over the USB connection, but with the additional hardware of the closed chassis adapter, you're also able to maintain through power cycles for different workloads you might need that for, particularly if you're doing a specific system bring up application. Another thing on this next slide here that we've done to help unify that experience and make it more uniform for our customers is on the software side. So that was the hardware way that we enable the tools, but on the software side here, we've also added something that we call the Target Connection Assistant. And this is something that we are pulling out of an already existing framework that exists in Eclipse. And on our Linux target versions of the tools, we have an integration of our tools into Eclipse. So if you're familiar with Eclipse, you've already got a leg up on it. If you're not, we've tried to make it as clear and easy as possible to understand what we're trying to do here. And one of the ways we've tried to simplify that, and I got the steps here just to give you a quick idea how simple it is we have that Target Connection Assistant, which enables you to simply, as you see on the left side there, so simply click a new connection, create a profile or a new connection type based on the kind of thing that you want to connect. So if you're connecting on an application level, you want to connect to a target, then we have that interface all integrated in. Or in this case, when we're talking about debugging, if you want to connect as a JTAG connection for using system debugger trace, all you have to do is click that and it'll handle all the configuration on the back end. There's a few more pages of the wizard that will just ask you to select your target system and things like that, but it's all very straightforward. And with that, as soon as you complete those steps and your host and target are powered on, then you are good to go and you can start debugging and analyzing your tool. And really our goal here on the debugger tools is to make sure that customers, people like everyone listening today, are able to easily and effectively use Intel hardware. Our goal is to make your guys' life easy. And so we're always looking to improve and enhance them as well. And it's a dynamic code base. So as you guys use and try the tools, which I highly recommend giving these a try, then we take your feedback, that's what my team does, and integrate them in to improve for the future generations to make the tools better as well. So that's debugging, and remember, make sure to file any questions you have for that, and I'll address them at the end. The next section I want to talk about is analysis. So when I say analysis, I mean our profiling, our optimizing, our power management tools that we provide. The first one, perhaps the most popular one, is Intel vTune Amplifier. Some of you may be already familiar with this. In case you weren't, I did want to give a a good introduction here. This is a tool that I greatly enjoy. This is something I always say I wish I had in college. You know, would have made my life much easier. So what vTune does is allows you in a either command line based interface or graphically, which is very advanced GUI, to view performance issues in your code. And there's many different features and tools that it supports and enables, but a couple here that I've called out on the first page is the first one on the left here is it will show you a breakdown for each of the different functions in your code and tell you how long that function was running. So when your program is running for say like a minute or 5 minutes or whatever your program is, and you want to improve that performance, making it run quicker, you go pick a function that seems like a good target and you optimize it all the time, and then when you come back and check, you've not changed your performance at all. And so the goal here is to say, well, let's look at what actually is taking the most time. So then when you optimize your functions, you can say, well, I could optimize that bottom one and get no performance gain, or if I could target my first function, then you see which functions could use the most, would give you the most benefit for your optimization efforts. Another one here is it helps you see where you're wasting time. So the example given here is cache misses. So you can look into your code and see if something is being programmed inefficiently, if maybe the structure of your loops or something is in the wrong way, or many different program optimization tricks you can look for. And if there's a way that you could optimize that, it'll call it out to you and point out that, well, there's clearly something going on here, so you can then focus your efforts there. Another one that often can be inefficient, especially when you're doing maybe OS development or anything with multi-threading, is locks and waits. So if you're running something with a mutex and it's holding your entire lineup because you're locking too aggressively or maybe inefficiently, then this gives you a breakdown, and you can set these parameters, but it gives you a breakdown of how long it's waiting, how optimal or how efficient it expects your current design to be, and then you can tweak it to and set the standards yourself. But you can tweak it then to be exactly within the threshold that you're targeting. Another one, waking up too often. This is particularly important. I mean, it's a performance issue, but also it's particularly important for power. Is if your system is a restful system and it goes to sleep, as many IoT devices are, you want it to stay asleep unless you actually need something, unless you need it to wake up. And what this does is it will show you how often you're waking up, what is causing those wake ups, and that will allow you to see that, well, maybe I don't need to wake up every 1 millisecond. I can wake up every 5 and still get the same workload accomplished and could vastly improve my performance and power management. So that's kind of the high level of the different main points of vTune. I want to go in here a little bit detail because it is such a great tool, and I included more screenshots here to give you an idea of what it looks like, though I highly encourage you to go try it yourself and see what it looks like. And so the different screenshots here, the first one on the top is the one I just showed you, where you can see the breakdown and how effectively you're utilizing your resources. And again, as I said, that's completely customizable. The other one is if you are profiling code, you can profile a completed executable and look at the assembly and step through that way. But if you have the source, say this is something you wrote yourself, then you also can link to the source and look through it on a source level and see the exact syntax and where you need to make the changes. So both are supported. And we also have a variety of different graphical representations of the data to help you highlight the thing that you're interested in different ways. And you see a couple more where here they have an example of tuning for OpenMP, and another one at the bottom where you're seeing there's a timeline. That's the wake ups and whatnot I was talking about, where you can see exactly which each thread is doing in your application and what is causing the memory or the power there or the processor and consumption at that moment. And the timeline is customizable, zoomable. You can set different settings to see which data you're interested in. It's a pretty flexible device, and definitely something that is very helpful for understanding how your system's working and how you can make it work more efficiently. So the next one, still in the realm of analysis and profiling tools, is called Intel Inspector. So Intel Inspector works in a similar mindset of how vTune works, in that it is there to help you make your program more efficient. But Intel Inspector is specifically designed to function around memory and threading issues. And we have a nice little example here. I assume most of you are familiar with a race condition, but just in case anyone isn't, what this diagram is showing here is that when you have multiple threads, if you, for example, didn't lock or make an atomic action correctly, then it's possible that your increment or your writings could be out of sync, and then the final result would be wrong. And that can be very difficult to diagnose. And things like memory leaks, for example, can be very harmful for your system. So when you have multiple threads, you want to make sure that your code is running properly. And so you need to make sure that you're checking for these kind of things. And to make that easier, as it is a difficult process, Intel Inspector is there to help you analyze and identify quickly what kind of issues you might be running into, or what optimizations you might be able to make your memory accesses and your thread control more efficient. And the next one, and I kind of hinted at this, is Intel Energy Profiler. So how this works is there's two parts of this. So one part is the analysis portion, where you run a profiling, energy profiling application on your target. And what it will do is it will collect the system performance for power management. And then you can either view that in the command line again and see what the data is in that way. Or if you prefer, you can bring it into vTune. And that's what we call our Intel Energy Profiler, is analyzing the power metrics in vTune to give you an idea of what sleep states and what power states you're operating in, making sure that your battery life or your power consumption is meeting your requirements. And if it's not, as usually it isn't in the early developments of an IoT project, then you can tune it using the different metrics and data you are provided from the analysis to see what is causing the workload. Another nice aspect of this that I really appreciate is because when you do a system level analysis and you're worried about the application performance of a certain task, you often discover that the thing that is consuming your system power may not actually be your application, but there may be some background task or other things that are going on that is affecting the performance of your application as well. And so it can help you root cause complex power management issues that sometimes just running through the code will never allow you to find. And the last one to talk about in the analysis and power tools is Intel Graphics Performance Analyzers. And this is sort of a suite within the suite. What we've done here is we've taken a number of different graphic performance analysis tools and bundled them together to make them all easily and readily accessible for you. And there's a lot of depth here, so I definitely recommend after this presentation, if you're interested, digging in. There's a great website they have that goes through all the different details. But the idea here is that whatever, sort of like the idea of System Studio, is whatever graphic development workload you have, we have a different tool tailored specifically for that use and for that need to help you be most efficient with your workloads and to make an effective product using Intel's hardware. And that is the profiler analysis section. So the next section I want to talk about is compilers and libraries. And so with that one, we will jump in first to the Intel C++ compiler. And this is a very powerful tool that Intel provides. Many of you probably already familiar with it, but if you're not, I just want to give you a brief overview of some key points of what the compiler is. So the compiler is compatible with Windows or Linux. We allow you to target any of the different targets that we have here, and we provide with that integration into some major different IDEs depending on what you want to target. For example, if you were targeting Linux development, Linux hosts, and I'm sorry, not Linux hosts, Linux target devices, then we have an integration into Eclipse on Windows host and on Linux host and on Mac host to allow you to do your development through the advanced Eclipse IDE with our usability improvements we've been making. And then if you're looking to target on a Windows device, so Windows host, Windows target, then we also provide Visual Studio integration, and new this year we're adding Visual Studio 2017 integration. so that if you're familiar with that IDE, you can take advantage of all the different features and benefits that it provides as well. And then additionally, we have a number of other integrations and IDEs that we support depending on what your specific workload and work and case might be. And we definitely recommend investigating what kind of tasks you want to do and which ways we can help best enable you. Another thing that is key about the Intel compiler, because it is made specifically to give a performance gain and to make your applications more efficient, is that it takes advantage of the latest and greatest of Intel architecture and processor features. One example is the support for the Intel AVX 512 instructions. And the idea being there that as Intel makes improvements in the hardware, we immediately want to enable those features, those improvements, those functionalities for all of you as customers with our software. And so the compiler is there specifically to do that. And as that, we are always adopting the latest and greatest of the C++ standards and adding in different optimization and profiling features, such as a couple I listed here, like the auto vectorization, profile guide optimization, those kind of things. And one thing that I think is really great is, in case you're not using Intel's compiler yet, we design our compiler specifically to be source binary compatible with GCC or the GNU compiler. And so if you're already using that, then our goal is to make it as a seamless transition as possible. So if you wanted to switch over and get that performance benefit on Intel hardware as well, then hopefully you won't have to do many changes or customizations to make it work and run with Intel's compiler as well. So the next thing to talk about is Intel's math kernel library. This library is one of the ones bundled in the compilers and library suite, and it is effectively for those of you who aren't mathematicians and for those of you who are. That's how I like to look at it. So for those people who don't want to write complex math functions and algorithms, we provide them all for you, so you don't have to go back to college and relearn all your different maths and everything. And for those of you who are familiar with math and are very interested in that field, then we have all these functions here tailored and optimized so that you can get in there and customize your applications to have the best performance, the most optimal performance when running complex mathematical equations such as FFTs, vectorization, working with neural networks, those kind of things. And this has a broad scope, and it's integrated with the rest of the tools so that you can use Intel's compiler, run the math kernel library, and then do an analysis on your tools. The idea of giving you a full immersive suite where you can run and profile with the different features we offer. Similarly, we also offer what we call Intel's integrated performance primitives. You see the 6 categories here. This gives you kind of a high-level grouping, similar to the math libraries, of different highly optimized and tuned algorithms for your system, bring up in system development, for your application development, for making sure that your code is secure, your algorithms are efficient, and that you are making the most of the features and functionalities that are available to you. And then a newer one that we recently added is the Intel Data Analytics Acceleration Library. This one is a specific library tuned around machine learning and around optimizing those complex workflows where you need to do, as you see in the workflow here, a lot of different analysis and processing of big data sets to make complex decisions. And so we've added that library to make that process, which has become very important to Intel in particular, make that process easier for our customers to use these kind of tasks. The next one I want to talk about here is Intel Thread building blocks. We mentioned threading a little bit earlier, and to enable your threading efforts, one of the things we've done is we have brought in this library. So instead of having to redesign the wheel and figure out threading again from scratch, you can just call some of our functions and it will handle in the back end all the optimization and tuning for threading that you might need for your application. And so if you're interested in doing a threading-based task, I highly recommend investigating this library to make your life easier and to get the performance gains that we've done by tuning these algorithms to make them more efficient. Okay, So those are the libraries and compiler. Again, same offer is make sure to post any questions if you have any, and I will check them at the end. It looks like we're doing great on time, so that's good. So the next thing I want to talk about is what are the new features of Intel System Studio. So this is for everybody, but particularly if you already knew the tools, then this is the new changes that we've made that you might be interested in. And if you just learned about them, now you know about the tools, so you can see what the interesting new things that we're offering. So the first one, and I kind of alluded to this, is that we've redesigned the way we're presenting the IDE. As I mentioned, for Linux target, that's generally Eclipse, and for Windows target, that's generally Visual Studio. And one of the things we do is we've added this welcome page when you first launch the tools. A lot of times when you download a new tool, it can be very confusing to understand what the developers were thinking and how to best access all the different features and functionalities. So right on the first page, you'll see we've added these key workflows, the three that I just described, the build, the debug, the analyze workflows, to sort of step you through how to access the different tools and features that we've been talking about, and to bring them up into a new project and to run them for the first time. Sort of an easy ramp into the different steps. So I highly recommend when you try these tools out to step through some of the workflows as you first go through it and kind of get familiar with the different features, and that will enable you to more effectively dive deep and get into the performance and the optimization features that are available there for you. Another thing that we've added into the IDE is container-based or IoT-based projects specifically. And what that is if you're familiar with Docker, we provide an integration in our IDE where you can create a project using a Docker container. If you're not familiar with it, it's a lightweight virtualization, you could say, of a certain target OS. One of the issues often that developers run into when you're designing for an IoT device is that your host environment where you're running your tools is quite different often than your target environment. And this can lead to some compatibility, cross-compiling challenges. And so to ease that burden, what we have done is we've created containers that will host a similar environment, a matching environment to your target on your host. You can build your project inside that container and then push it to your target. And that allows you to use your normal development system to still target your IoT device in a more seamless way. And as part of that, we've added a sensor support window. And that sensor support window is there to ease the process of attaching different sensors, IoT sensors and devices, into your project. And so it has an integration there to locate, find documentation, find code samples, to bring them in and to attach them to the different things that you might be working on. And the next thing, and related to that sensor window that I just described, is new in the tools is we have now added what we call the sensor library, which is a very large collection of samples and code base and documentation and instructions around different IoT and industrial sensors that you might want to use for your projects. And we've worked to make them more seamlessly integrated into the tools so that if you are interested in using any of these things, you can get started and get ramped up very quickly by just importing them into your project. And this is taking advantage of our MRA hardware abstraction layer, and then our sensor framework, which is the top level with a collection of high-level APIs that we call UPM. And I have a few examples here of some of the different sensors that have been enabled already. And this is a live and growing project as well. The next one I want to call out, and I had mentioned this one earlier as well, is the cloud connector support. So what cloud connectors are is the idea is that there are a number of cloud-based web services up there that handle IoT data, handle workloads that you want to push up from your gateway or from your IoT device up to the cloud. And what we've done is we've provided a number of samples to show you how to interface directly with those things from the tools to provide that seamless integration from building your application on your host device to pushing it up to the cloud and integrating it with your ecosystem that you might already have up there, or if you're creating a new one, to create that new ecosystem without requiring learning extra tools and going through extra process. And the last one here, I wanted to call it as a new feature was, or is the target communication framework. If you remember earlier, I mentioned the TCA. That is part of this. So what that is it is a unified method for connecting and building, it's not building, connecting and targeting different devices in the IDE. So normally when you build an application, you run it one way. When you debug a project, you run it another way. And to make that simpler, we've made one wizard, one connection interface for all the different workloads. So you just go into there, as you can see in the screenshot, and select which kind of connection you want to make and just step through the wizard, and it will handle all the connection details on the back end so that what you can focus on is writing your code, developing your applications, and making your project as good as you want it to be, and not worrying about the interface of how it is done in the back end. So to summarize the what's new, or the new features of Intel System Studio, and then to summarize Intel System Studio as a whole, I think I would boil it down to these three main points here. So Intel System Studio is here to help you get better performance and greater power efficiency out of your code and out of your projects by utilizing the best of Intel hardware and then enabling that through the different software tools, features, and libraries to speed your system and IoT application development. So through the new IDE interfaces, through the new workflows, through the sensor libraries, to help you write your code quickly and with higher security, higher quality, and then to strengthen system reliability, which is to help you bring up your board, design your new system, debug, trace, analyze those different low-level issues that can be a barrier to successfully getting a product out the door. And to do that all in one unified way, so that from beginning to end, if you're developing on Intel hardware, then you can develop with these tools and make your product successful and effective. And if you're interested in seeing the full list of all the new features, I know this was just a quick overview, but we have a website. It's public. Anyone can go there. And I believe you're going to get these slides. And so I highly recommend checking out, reading through the new details, checking out the product page. And actually, my next slide here is I would like to leave everybody with a challenge to go and try the beta. We have an open beta right now for Intel System Studio 2018. I have the link right here on the page. Investigate, see if you have any questions. We have teams of people like working the back end to make sure these tools are amazing for you, and then to help answer any questions you might have as well. And if you're interested in trying any of the older versions, say Intel System Studio 2017, which is currently public and available, then I also have included the link here at the bottom. You can either eval and try a free trial to see what the different features are and functionalities there, or if you're interested, you can purchase the tool and get access to all the different features, functionalities, and the support for the tools that it provides. So that is everything for me. I've got this nice little legal disclaimer. I'll just flash up there. So what I'll do now, I will minimize this, and I will flash back to my pretty face here. Hi, everybody again. And then I'm going to start looking through some of these questions and seeing what I can do. And I also saw, hi, thank you. So I also saw that there were some questions in advance, and so I took a look at a few of those that I wanted to look at as well. So let me just hit on the questions people asked in advance first real quick, just to see that we're addressing those people who were prompted about it, and then I'll go through the chat and make sure that I answer all of your questions as well. And I gave let's see, I gave about 20 minutes, so we can go through for about 20 minutes and see as many as we can get through. So one of the first questions I saw on the group chat there was what are some good use cases for IoT in terms of business and technical maturity? And I think, my computer is trying to restart. Just give me a minute here. So I think one of the best use cases I can think is what I would recommend is going to the Intel System Studio product page and looking through, we have a section there on use cases where you can look up the different use cases that we have had with customers who have agreed to share their situation. We've used cases with, say, automotive and automated driving. We have use cases with several IoT vendors, with several system bring-ups, developers, things like that. So I recommend just reading through there, seeing what the different things are available. There's a great wealth of resources there. And if you have any questions, of course, our team is always happy to help and answer any questions that there are. So going next, the next one I saw was how the end customer of a particular use case can calculate return of investment out of it. And so I think what we address in the tools is really the key to this. So how Intel System Studio works is our goal is to help you get your product to market, to optimize it, make it efficient, and help you design and bring up your system more efficiently. And so when you're talking about return on investment, I think the idea here is that when you're designing a new thing, a new device, then our goal is to make it as easy as possible and as efficient as possible for you to do that. So to whatever your great ideas are, as I'm sure all of you have great ideas, and then to make that success by using our tools. So to prevent you from running into those normal barriers that people run into when you're trying to design a new project. Okay, so one of the questions here is we used to have the Intel XDK IoT. What are the key differences? So I hope that I've highlighted in the discussion what the features of Intel System Studio are, so you understand that. One thing I do want to mention is that one of the goals of this year with the release of Intel System Studio is that Intel has a lot of IDEs and development tools. And so one thing we've done is we've brought in features from many of those different tools into Intel System Studio so that we could then make sure that all of the customers don't have to go and switch from different products each day, that instead you can just, like Intel System Studio, for example, download that and run all the different application development system bring workflows you might need. So instead of switching between like the XDK or the dev kit or the different things, our goal is to bring that all in so that anything you need will be in this one suite for IoT or embedded development. Now, given there are other other workloads, say if you're doing HPC, we have the Intel Parallel Studio suite, which is a suite for the embedded in IoT. Our goal is really that you have everything you need in Intel System Studio. This is a good question. So next question, want to know if we using C++ compiler on the Windows platform that will code after compiled will work on Linux, CentOS, or Ubuntu. So generally speaking, so the same Intel C++ compiler works on all the different Linux or Windows targets. Well, the Intel C++ compiler, there are differences between them. If you're familiar with the Intel compiler, ICL is the Windows target one, and then ICC is the Linux one. And so if you're building for Linux, you should compile on Linux. If you're building for Windows, you should compile for Windows. So there are differences in the libraries and the backend tools and functionalities. So it will work for both, but generally you should compile your code for the platform you're targeting. Okay, next question here. Do you know how or when Intel System Studio is needed when the developer is using Windows Workbench already? That's a good question. One thing I think I mentioned on is one of the tool or the IDEs or environments that Intel System Studio integrates into is Wind River Workbench. So if you are using that, our tools will pull into and be part of that environment as well. I'm probably not the right person to ask about when to choose one or the other. So actually, I would say contact the Wind River team and ask that question. I think that is a good question, though. And definitely invest. You can find out there. Okay, next question. So it says, if I'm using Visual Studio 2017, Will we be able to use these tools and compilers from within Visual Studio 2017? So that's a great question. So the compiler and the libraries are integrated if you're targeting Windows into Visual Studio 2017. So you can pull the compiler, pull the libraries, all this stuff will work wonderfully. Some of the other tools are integrated. For example, the WinDBG, also for Windows Target, is an extension, is integrated into Windows WinDBG product. If you're using the system bring-up tools, then they have their own IDE. They will not be launched from Visual Studio, but you would launch them independently as part of it, as part of the system bring-up workflow. Since Visual Studio is really specifically for application development, we haven't integrated the non-application development tools into it. But good question. All right, next question is a compiler question. It says, is the ICC deterministic or can it be made so? And gives what they're talking about here. There are different flags in the compiler that you can customize it to affect how deterministic it is. We have compiler optimization and performance guides specifically around those kind of topics. What I recommend is research the different specific tasks you're looking for and see which flags will meet that need. And so there is a level of deterministicness that you can have in there. I don't know if I should comment specifically about any flags here, but I think good. And if you have any trouble figuring out exactly which flags for your workload, then we have, it's in the slides, then we have a site where you can ask questions. We have a forum where you can post and ask your compiler questions, and then we can answer those things that worst case in your workload. Good question. Okay, next question. Does the studio work with Intel hardware only? So the suite of tools is designed specifically and functionality for Intel hardware. In theory, some of the tools may or may not work for other things. I'm not really, I think, going to comment on like which ones you could use it for. I think it would be like with each case. So definitely you could use some of the tools for different hardwares and whatnot. But I would say it's a case-by-case thing. Obviously, there's a lot of different hardware out there, and so we don't guarantee that it will work with everything. But we do guarantee that it is specifically designed to give you the best on Intel hardware. That is our focus. And then the last question we have here is, how can a student make the best use of video? That is a great question. I love that. So my first response would be use it. Like I mentioned, there's a free beta right now, and so if you want to go on there and try out the tools, that would be very useful to you. We have a number of different student-based programs on our website, so if you research around, you can see different ways. We have stuff specifically for students to help get started and to learn and to get a good understanding. If you're a new user, whether a student or just someone who's trying it out for the first time, I mentioned it in the slides, but going through that welcome page and trying the different workloads, the workloads where they explain, well, here, you want to build an application, or you want to bring up a system, or you want to analyze your target, and just try those and see what you can do with the tools, get a kind of a taste for it. Then additionally, for anyone else who wants to go a little deeper, we do have a number of, like I said earlier, use cases and tutorials you can get to. We have code samples, a lot of different articles, depending on your interest, on the web page, which is in the slides. And that will give you access to a wealth of resources to help you get started and to understand what the features and capabilities are in the tools. Somebody is asking about Raspberry Pi and Arduino. There's several different Arduino products and whatnot. It's not specifically designed around Arduino, but we do have features for Arduino specifically in the tools. And I definitely recommend going into the documentation to get the details on that specifically, because that is a big part of the makers or the IoT space and industry. Okay, looks good. Well, thank you everybody for all your great questions and for hearing me out. And please go check out the tools, try them out. Let us know if you have any feedback. We'll be following up with it to see if you have any feedback and answer any questions. Then, of course, we have the forums and all the different pages and resources available as well for anyone who wants to investigate and dig deeper. Thank you for all your great questions and everything, and have a great day.